In this lesson we're going to look at calculating the area and perimeter of some different types of shapes. Firstly, we can start it here. Let's draw it quickly. So if we draw this, there we have 1 centimeter here, 1 centimeter here, basically all 1 centimeters. We have 2 centimeter there. But we haven't been given the distance from here to here. But the first job we need to do to find the area within here is to break the shape up into small segments. So let's put a dotted line here to break that into a little square. Let's put a dotted line here to break that out into a rectangle, and see if we can work with this. So let's name this area here area 1, area 2, and area 3. So we calculate each area separately, then we add all the areas up to get the total area there. So let's calculate area 1. So area 1 equals this side by this side here, so it's 1 by 1. So 1 by 1 equals 1, and the units are centimeters, so it's centimeters squared. Okay, that's area 1. Area 2 equals, it's this length here plus this length here. So if we have a look at the top there, we have a distance of 1 there, a distance of 1 there, and a distance of 1 there. So that is the same as the distance all the way across here. So 1 plus 1 plus 1 is 3. So it's 3 times 1 equals 3 centimeters squared. So remember, for the area of a square or a rectangle, we multiply one side by the other side. Area 3 equals the distance here and the distance all the way across here. So the distance vertically we have written here is 2, so it's 2 times the distance between here and here. But that is the same as adding all these small distances up. So we have 1, 2, 3, 4, and this distance here is the same, it's 1, so 1, 2, 3, 4, 5. So 2 times 5 is 10 centimeters squared. So we can write now the total area equals the addition of all these smaller areas. So 1 plus 3 plus 10 equals, that is 13, 14. Notice I didn't put the units in the equation itself, I only put the units on the answer. That is to keep it neat and tidy. So the total area of this shape is 14 centimeters squared. For area, we always have that power 2 on the units. Now the perimeter, let's calculate the perimeter, P. We know this distance here to here is 5, we calculated that before. And we know the distance of this one is 2, because it's the same as this one from there to there. So we just add up all these numbers. So let's start from the 5 and go anti-clockwise. So 5 plus 2 plus 1. We know this is 1 as well. Plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 and 2 plus 2. Let's just check we got that right. Count the number of ones up. So 1, 2, 3. We missed 1 here, so we're going to have to add another 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we've got 2 2s there, 1 5, there. So that should be the perimeter. Let's count the ones up first. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 plus 5. And the 2 2's, add them two together. So that's 4. So this is 14, 18 centimeters. Okay, so that's that one out of the way. Let's rub this out and do the next one. Let's do number 2. Okay, let's draw the problem first. We have 10, we have 3, 2, 2, 2, 6, 2, and 15. Okay, let's break this into segments. So let's break it, let's go down here. And let's label the segments. So A1, A2, A3, A4. So let's calculate each one separately. A1 equals 6 times 2 equals 12 centimeters squared. A2 is 2 times. Now we need we know the distance from here to here. We need the distance from all the way down to there. We know the distance from here to here is 2, and we know the distance from here to here is 2. So that distance from there to there is 2. So 2 plus 2 is 4. So it's 4 times that distance from there to there equals 8. A3. So we know the distance from here to here is 3. What is the distance from here to here? Well, it is this 2 plus this 2 plus this 2. So that's 2, 4, 6. Area 4. We know the distance from here to here is 10. And we don't know the distance from here to here. But we know the distance from here to here. So, and we know the distance all the way up to this point. So the distance from here to here is 6 plus 2, which is 8, plus 3 is 11. So if that distance from there to there is 11, and that distance from there to there is 15, we can calculate the distance from here to here. So 15 take away 11. So 15 take away 11 equals 4. So we have 4 here. So 10 times 4 is 40 centimeters squared. Okay, so the total area equals A1 plus A2 plus A3 plus A4 equals 12 plus 8 plus 18 plus 40. That is, let me get my calculator, 12 plus 8 plus 18 plus 40. That is 78. So 78 centimeters squared. That is the total area of this shape. Now let's calculate the perimeter. So the perimeter equals, adding up all the distances around the shape. So first we have 15 going in a clockwise direction, plus 2, plus 6, plus 2, plus another 2 plus another 2 plus 3. That distance from there to there, we did calculate that before, so we have 10 there, 2, 4, 6, that is 4, so let's write that in there, plus 4, plus the distance across there, which is calculated as before, 4. Distance down there is 15. Okay. 10, sorry. So let's add all these numbers up to get the perimeter. 15 plus 2 plus 6 plus 2 plus 2 plus 2 plus 3 plus 4 plus 4 plus 10 equals 50 centimeters. So that is the perimeter of that shape. Let's rub this all out. Okay, let's do number 3. We want to calculate the area of the blue, shaded blue part only, but not the white part, the white square. So how do we tackle this? Well, looking at the problem, we can see there's a large rectangle and there's a small square within that rectangle. The size of that square within the rectangle is given, where you can see the dash on those lines, which means each side has a length of 5. That's what those dashes mean. So it's a square, so we can calculate the area of that small square. We're also given the size of the rectangle. We have a 9 centimetre here and a 7 centimetre here. So if we can calculate the area of those two shapes, we can find the area just of the part we need. So the total area equals, we call this A1 and we call this A2, the blue part, which includes this part around here. So the total area equals, or just the blue area equals A2. So the total area A2 using this measurement and this measurement minus the area of that little square, so A1. So let's calculate the area of A2, the large rectangle. So it's 9 centimetres by 7 centimetres, which equals 63 centimetres squared. But let's go back one step before we calculate that. Let's finish the calculation here. So A1 is 5 by 5, so 5 by 5 centimetres. So we have 63 centimetres squared. Take away 5 times 5 is 25 centimetres squared. So 63 take away 25. That is 38 centimetres squared, which is the blue part of that rectangle. Okay, let's move on to the next problem. We have this problem here, number 4, and we want to calculate the area of this little part going around the edge here, and we also want to calculate the perimeter. So the perimeter of this, it might be a bit of carpet, and if we put it all in a straight line, we'll get our length. Okay, so let's firstly calculate the area. So we have this inner rectangle here, and we have the larger rectangle. We're given the dimensions of the large rectangle there. So let's firstly calculate the dimension of the large rectangle. So the area of the large rectangle equals 8 times 17. So that is 136 meters squared. And let's see if we can calculate the area of the inner rectangle, so the smaller rectangle. So the area of the smaller rectangle equals, we know this distance from there to there is 8, but we can have these two measurements as well given to us. So the distance from there to there and the distance from there to there. So if we look, it's the same as this side. So we come down, move in 1, and here we move in a unit of 1 there. This reduces the 8 by 8, take 1 and take another 1, which gives us 6. So the distance from there to there is 6. What about the distance from here to here? Well, we know the distance from there to there is 17, but we move in 1 unit there, so we move in 1 unit there, we move in 1 unit there. So 17 take 1 is 16, 16 take another 1 is 15, so that is 15. So now we have the dimension of the smaller rectangle. It is 6 by 15. So 6 times 15 equals 90. That's meters squared. So because we now have the area of the whole object and also the area of the inner rectangle, you can calculate the area just of the outer perimeter there. So it'll be the area of perimeter, we can call it, equals the large area take away the smaller area inside. So that is 136 take away 90 equals 46 meters squared. So now we have the area of that shaded bit around the outside there. We just need to calculate the perimeter. So the perimeter equals, now we want to calculate the perimeter in the center of that shaded bit. So this here is 0.5 in the center at 0.5, and this here is also 0.5 in the center to the center of that shaded part. So instead of coming in 1, we come in 0.5. So that is the same as reducing the length here, the total length 17 by 0.5 plus 0.5, which is 1. So 17 take 1 is 16, and 8 take 1 is 7. So the perimeter equals there to there we now know is, in the middle part is 16. And the middle part there is 7. So it's 16 plus 16, so one there and one there, plus 7 plus 7 equals 32 plus 14 which equals 46 meters. So that is the perimeter. If we were to measure in the center of that shaded part all the way around, we would get 46 meters. So that completes this lesson on calculating the area and perimeter of different types of shapes.